Hello students, welcome to the course of Ultronic Testing Technology. This class mainly introduces ultrasonic testing experiment. 2.1 Determination of instrument level linearity. First of all, the horizontal linearity is ultrasonic detector that is also called time-based linearity, which refers to the extent that the actual sound path when the ultrasonic reaches the reflector is in direct proportion to the horizontal scale value of its corresponding echo on the instrument oscilloscope screen. The horizontal linearity of the instrument is mainly described qualitatively by the horizontal linearity error value, which is mainly caused by the factoring error of the instrument. The better the horizontal linearity of the instrument, the smaller the horizontal linearity error value measured and calculated. On the contrary, the worse the horizontal linearity of the instrument, the greater the horizontal linearity error value measured and calculated. The horizontal linearity of the ultrasonic testing instrument has a close impact on the accuracy of the defect positioning results of the workpiece to be tested. Therefore, before ultrasonic testing of the workpiece, it is generally necessary to measure the horizontal linearity of the instrument. Only when the horizontal linearity measurement results of the instrument meet the requirements of the relevant testing standards, the instrument can be used for ultrasonic testing of the workpiece. And next, let's learn how to determine the horizontal linearity of the ultrasonic testing instrument. The test block used to determine the horizontal linearity of the ultrasonic detector is CSK-1A test block. First, place the test block horizontally. Place the instrument's depth course adjustment at the gear to be measured. Because the thickness of the test block is 25 mm, select the gear of the 50 mm for depth course adjustment here. Apply a small amount of coupling agent to the surface of the test block. Place an ultrasonic straight probe in the middle of the test block and keep the echo constant. Adjust the depth fine adjustment and the pulse shift knobs to make the first wave T and the phase button echo B1, B2, B3, B4, B5 appear on the oscilloscope screen, and adjust the leading edges of B1 and B5 to align with the horizontal scales 2.0 and 10.0 respectively. Seriatically, the ultrasonic sound pass with equal difference between two buttons waves. Therefore, when B1 and B5 are aligned with 2.0 and 10.0 respectively, B2, B3, and B4 should be aligned with the horizontal scales 4.0, 6.0, and 8.0. But, in fact, we will find that B2, B3, and B4 are not completely aligned with 4/6/8, but there is a certain derivation. The derivation here is the main measurement data in this experiment. The specific measurement method is: first, adjust the attenuator to adjust B2 to the fixed vertical amplitude, such as 80% of the vertical amplitude and read the horizontal scale value corresponding to the front edge of B2 minus the theoretical value for point 0 to obtain the first measurement duration, which is recorded as L1. Note that the 2 decimal places should be reserved for the reading here. Note the echo front here is the intersection of the pulse echo on the indicator wave screen and the lower left corner of the horizontal time baseline. Then adjust B3 to 80% of the vertical amplitude and read out the horizontal scale value corresponding to the front edge of the B3 minus the theoretical value 6.0 to obtain the second measurement duration, which is recorded as L2. By analogy, the third duration L3 can be obtained. Take the absolute value of the maximum derivation among the 3 derivations into the calculation formula. Delta L is equal to the absolute value of the maximum derivation divided by the quotient of the 0.8b and multiplied by 100% to obtain a horizontal nonlinear error value of the instrument. According to the standard NB/T47013/2015, the horizontal nonlinearity error of the ultrasonic detectors shall be less than or equal to 1%. Okay, that's all for the method of measuring the horizontal linearity of the ultrasonic detector. Next, we will introduce the ultrasonic testing experiment 2.2, measuring the vertical linearity of the instrument. Therefore, the so-called vertical linearity, it can be understood as the degree of linearity of the echo sound pressure formed by the reflector in the workpiece received on the ultrasonic probe element and the corresponding echo height value of the reflector on the oscilloscope screen. Generally, the difference between the measured echo height and the theoretical wave height is used to reflect linearity. The parameter is an important technical index of the ultrasonic testing instrument. First of all, we know that the transmission and reception of the ultrasonic wave in the ultrasonic flow detection process is actually the mutual conversion process between electrical energy and acoustic energy. After receiving the ultrasonic sound being reflected by the reflector in the workpiece, the probe converts the received sound pressure signal into a voltage signal and transmits it into the instrument through the cable. Since the voltage signal is very weak, it is necessary to use the amplifier to linearly amplify the signal and then apply it to the vertical deflection plate to generate an echo signal. Therefore, although the sound pressure received by the ultrasonic probe has a positive proportional linear relationship with the voltage on the vertical reflection plate, and the voltage on the vertical reflection plate has a positive proportional linear relationship with the echo height on the oscilloscope screen. However, due to the linearity error of the instrument amplifier when amplifying the voltage signal, therefore, there will be errors in the above linear relationships. Generally, the difference between the measured echo height and the theoretical wave height is used to reflect linearity, which directly affects accuracy of defect qualification. In this experiment, the signal amplification factor is changed by adjusting the attenuator, and the measured echo height of the reflector is compared with the theoretically calculated echo height to obtain the wave height error value, which is used to describe the linearity amplification error of the amplifier. The calculation formula of the theoretical wave height is shown on the screen. Among them, delta dB is the change value of attenuator reading. Representing the change value is instrument magnification. L represents 100% of vertical full amplitude, and L represents the theoretical wave height. Look at the formula. The test block used in this experiment is CS1 type cylindrical test block. The reflector is also the flat bottom hole at the bottom of the test block, which is located at a depth of 25 mm from the bottom of the test block. Select one test block of this type of median height. Place the flat bottom hole downward on the desktop. Apply an appropriate amount of couplant on the testing surface. Place the ultrasonic straight probe at the center of the test block to radiate ultrasonic wave toward the depth of the test block and detect the flat bottom hole at the bottom. At this time, the reflected signal from the test block will appear on the oscilloscope screen. The highest echo pairing after the initial wave T on the oscilloscope screen is the first reflected echo B1 on the bottom of the test block, while the reflected echo F of the flat bottom hole is located between the initial wave T and the bottom reflected wave B1 and close to B1. Adjust the attenuator and gain knobs so that the reflected wave F of the flat bottom hole between the starting wave T and the bottom wave B1 just reaches 100% of the vertical amplitude, and ensure that the attenuator have at least 30 dB of margin for adjustment. Adjust the attenuator to reduce the magnification by 2 decibels each time. Record the measured height of the reflected echo from the flat bottom hole after every 2 decibels reduction, until the echo from the flat bottom hole on the oscilloscope screen cannot be identified. According to relevant standards, this process requires attenuation of at least 26 dB, that is, at least 13 times of attenuation of 2 dB, and 13 measured wave heights are recorded. In addition, it should be noted that the process of adjusting the attenuator, one hand should always hold the probe with constant pressure to make the adjustment under the condition that the echo height of the flat bottom hole is stable. Calculate the difference between the measured wave height and the theoretical wave height of the reflected echo from the flat bottom hole under each attenuation amount, and select the maximum positive derivations d plus and the maximum negative derivation d to bring into the calculation formula. Delta dB is equal to the sum of the absolute value of the maximum positive derivation plus the absolute value of the maximum negative derivation, which is vertical linear error of the instrument. The standard MBT 47013-2015 stipulates that the vertical linear error of the ultrasonic detector should be less than or equal to 5% before it is qualified. Well, that's all for the vertical linearity measurement experiment of the ultrasonic detector. Goodbye.